class data that we have tally marks there in the back of the room. We're going to go ahead and just transfer that here onto our packets, into our table, but we're going to turn it into an actual number. So I'm going to start with what looks easiest to me. So it looks like we've got 8 people that are in this yes, Little Caesar cheese category. We have 3 people over here that are no Little Caesar in the meat category. And then let's see here, we have 1, 2, 3, 4, 5, 6, 7, 8, and then there's a little flash through. Then we have 9 people up here. And then in this last little section here, we have 3, and then we didn't have any tallies in these 2 pieces. That's all right. We're just going to go ahead and fill in zeros there. So this is interesting. Actually, most of our class seems to have preferred Little Caesars. We only have a few people in the no category. All right, but this is going to be some good data that will allow us to work through our activity today. So we're going to go ahead and start by filling in the totals at the edge of each column, at the edge of each row, and then we're also going to figure out a table total. So we can start by just adding up. So the total number of students that preferred meat was 12. Total number of students who preferred veggie was 3. We had 8 students that preferred cheese. And then we'll go ahead and do the same thing here across on this side. So the top row, the people who preferred yes, Little Caesar, we're going to be doing 9 plus 3, which is 12, plus 8, that's 20 students. And then we just have 3 students in this whole bottom row. If we had other numbers in those positions, we would go ahead and add those up to get the total number of people who do not prefer Little Caesars. And then we could add together either the 20 and the 3 from the row totals, or we can add together the 12 plus 3 plus 8. Those are all of our column totals. Either way, we should get to our grand table total of 23 students. That's the amount of people that we just collected information from. All right, so using the data here, the numbers in the table, we are going to start to move through these questions. So we're going to take a look at one of these together. So it says, suppose that we randomly choose a student from class. We're going to start by finding the probability that that student prefers meat. So you'll notice the probability notation that we're using here is what we did in the previous lesson. We're doing a capital P for finding the probability of that event. Whatever's listed in the parentheses is what we're finding the probability of. So if we take a look at our table here, it looks like the total number of students who preferred meat in the class was 12 out of the total of all the students we surveyed was 23. So we're going to write this probability as a fraction. Again, today, it will be 12 out of 23. And actually, I would prefer that you leave everything in fraction form today. No need to turn it into a decimal or a percent, although we could. The fraction will be just fine for the form. So I'm going to give you a little bit of time here. I'd like you to continue working through the rest of number 2. Go ahead and work through number 3, and then I'd also like you to try number 4. And we'll come back together here in a few minutes after you've had a chance to work through and take a look at those remaining questions. All right, so we're going to start to go through these together. And I have some good questions come up. There's some interesting things that are happening here in number 3. But let's take a look here at just finishing number 2. So if we thought the probability that the student preferred meat was 12 out of 23, would someone be willing to share out what was the probability that a student prefers cheese? Go ahead, Benjamin.
8 out of 23.
8 out of 23. Okay, so now we wanted to know the probability that the student preferred meat or cheese. What did you all get for this one? Go ahead, Max.
20.
And how did you get 20? Or what did you look at to get 20 out of 23?
Just add the numbers.
So if we were to think about sort of writing this as an addition statement off the side here, it looks like we took the number of students who preferred meat, which was 12, and then we had the number of students who preferred cheese, which was 8. We add them all together, we have 20 students altogether that are either meat or cheese out of the 23 students in the class. Okay, so we're going to try a little something here. So let's actually take a closer look at who the students are in the room that fell into these 2 categories. So I'm going to actually have you stand up if you are one of these 12 students and you said that you prefer meat on your pizza. So go ahead and stand if you prefer meat. All right, now I would like to have the 8 students in the room that said that they prefer cheese to stand up. Okay, so notice what happened there. All of the people from the first question sat down when the people for the second question stood up. You guys can go ahead and take a seat here. But it looks like there was no overlap at all in the ways that people answered those 2 questions. People either preferred meat or cheese. It wasn't possible to prefer both of them. So that was completely 2 different sets of people that were just standing. All right, well, let's take a look here at what's happening in question 3. So it says here, suppose that we randomly chose a student from class. The next question here, so what was the probability that that student said, yes, Little Caesars? Mark, what did you get for that next answer? All right. Then we're wanting to look at the probability that the student preferred meat, which is a really common one that we've been asked today. So let's just go ahead and copy that answer down before we got 12 out of 23. And now we want to find the probability that the student prefers, yes, Little Caesars or meat. Well, let's take a look at what we did up here in part 2. When we wanted to find the probability that the student preferred meat or cheese, we simply add those 2 separate probabilities together. Well, what's going to happen here when we try to add together the people that prefer Little Caesars, so that was 20 out of 23, and we add that to the people who preferred meat, which was 12 out of 23. Well, it seems that maybe I've made a mistake here because I'm getting a fraction that's not possible. Here I have 32 students, but it's still only out of 23. So we need to make a little adjustment here to our process. We know it's not possible to have a probability anything that's bigger than 1. So there's something interesting going on with the way that these 2 questions are being asked. So we're going to try the standing again. So I'm going to ask the first group here, students who said yes to Little Caesars. I'm going to have all of those students stand up, which I know is almost all of you because 20 people said yes, Little Caesars. And I want everybody to just kind of take a careful look around the room. Let's see who's standing. All right, now for the second set, go ahead and stand if you preferred meat. All right. We had a few changes here, but notice how a lot of the students who were standing for the first answer are still standing for the second answer. You all can go ahead and take a seat. And so what that's telling us here is that some of the people that were counted in this 20 were also counted in the 12 because they're standing up for both of the questions. And so we have some overlap here. We have some people in the room that were double counted. Well, let's take a look back at our 2-way table. How can we determine the number of people that were double counted? Which one of these numbers represents the number of people that were standing twice? Go ahead, Remy.
The 9.
Yeah, so it is the actual overlap in the table. If we were to look at all of the students who preferred, yes, Little Caesars, so that would be this whole top section here, and put a loop around those students. And then if we go ahead and look at the people who also prefer meat, we can see that we have this section here of overlap. So it's these 9 students here that are included in the total of 20, but those 9 students are also included in the total of 12. And when we did that switcheroo with the 2 questions, it was exactly 9 students in the room that were still standing for both questions. So if we were to put that back over here into our answer, what we're going to do with that 32 over 23 is go ahead and subtract the overlap. We're going to subtract the number of students that were double counted. And actually what's interesting about this answer is it ends up being 100% of the class. It's not always going to be that same result, but for us, we ended up getting the full 23 out of 23. So we're not going to do this standing, but if I were to ask the question, stand up if you prefer Little Caesar, or if you prefer meat, we should have everybody in the room that's standing. And what's interesting about this result, that actually has to do with the fact that the only 3 people that did not prefer Little Caesars all happened to prefer meat. So that's happening because we have some zeros over here in these other categories. If we actually had some students filled in either of these 2 positions, it wouldn't necessarily have been 23 out of 23. It might have been close, but that's the reason why it's encompassing everybody in the whole class. All right, so we're going to pause here and just summarize a little what we have seen so far in questions 2 and 3. And so if you have that different colored pen with you, go ahead and take that out. I'm going to switch to red. We're going to put in some different colored little notes off to the side of what we've done so far. All right, so we're actually going to go back up here to the situation in number 2. So this is where we're looking at 2 different events, the probability that somebody prefers meat compared to the probability that they prefer cheese. Well, those 2 events, meat and cheese, are considered mutually exclusive events. And mutually exclusive means that this cannot occur together at the same time. There's no overlap here. I made everybody choose one option, so the people would either have to have chosen meat or cheese. It was not an option for them to choose both. And when the events are mutually exclusive, this basic addition rule works just fine. So if I want to find the probability of meat or cheese, and I know that there's no possibility for anybody to be double counted, there's no overlap, we're just simply going to add their separate probabilities together. So we're going to write off to the side here the formula that we're using if they are mutually exclusive, which is that same little formula that we saw on Friday. So the probability of event A or event B is simply taking the probability of A and adding that to the probability of B. All right, now looking at the situation that we did here in number 3, we were looking at yes, Little Caesars versus preferring meat. And what we saw is that those events could occur together at the same time. Somebody could prefer Little Caesars and prefer meat on their pizza. So if that's the case, we're going to describe this as not mutually exclusive events. And so if they are not mutually exclusive, and we're wanting to find the probability of one or the other, our formula now is slightly changing. So here we saw that if we wanted to find the probability of 2 events, A or B, well, we started off by doing the probability of A plus the probability of B. But then we noticed that we had to do this part here. We had to subtract those people that were double counted. And the way we're going to describe that overlap mathematically is the probability of A and B, meaning the probability that they prefer, yes, Little Caesars, and they prefer B. That's how we figured out those 9 people, is that they were a yes to both of those questions. All right, so now we're going to take a look at, we have kind of some different style of questions showing up in number 4. So it says again, suppose that we randomly choose a student from our class. We're going to use the probability that they prefer meat, again, which we've done many times now. That's 12 students preferred meat out of our class of 23. Let's take a look at the next part here. So now we want to find the probability that they prefer meat, given that the person is, yes, Little Caesars. So let's take a look back here at our table. And we're just going to focus in on the part of the table matching the question that is being asked. So we just want the yes, Little Caesar people. So I'm going to physically cover up everything else. Notice how it was a total of 20 students that said yes to Little Caesar. Now the probability of those 20 students who preferred meat were these 9 students here. So we'll answer this by saying 9 out of the 20 that preferred Little Caesars in the first place. So notice that we are changing our denominator. So instead of it being out of the whole class of 23, the denominator is matching whatever this condition is. So the condition is that the person said yes to Little Caesars. It was only 20 people that said yes, so we get a new type of fraction. All right, so now if we take a look at the next one, it's kind of asking us the opposite thing now. So the probability that the student preferred meat, given that they were a no Little Caesars. Well, if we're only looking at the people that said no to Little Caesars, well, now we can cover up this part of the table that we don't need. And we only had 3 students that did not like Little Caesars. Well, what's interesting here is that all 3 of them preferred meat. So it's 100%. It's 3 out of 3. If they did not like Little Caesars, it was a 100% chance that they preferred meat. Oh, there we go. Sometimes this freezes a little bit. So I'm going to highlight this little portion again, that this given statement is telling us what our denominator would be. All right, so what we have just looked at here, when our denominators change, this is what we call a conditional probability. And the name makes sense here. If we think about what's going on, is that we have to meet a certain condition. So given that this condition has been met, what is the probability that a certain event happens? And initially, we have this written out in words. I want to show you off to the side over here mathematically how a conditional probability could look. So looking at this first scenario, that 9 out of 20, would be the probability that a randomly selected student prefers meat. Now, instead of saying given that, we're actually going to draw in a vertical line. And let's make a little note off to the side there that when we see that vertical line, it means given. If we were to write it, or if we were to say it out as a sentence. So the probability that the student prefers meat, given that they are yes, Little Caesars. It's just kind of a little shorter way that we can express that statement. And then similarly down here below, this one, what we just did, was the probability that the randomly selected student prefers meat, given that they are a no Little Caesars. All right, now question 5 is asking us, well, what do our results from number 4 tell us about the preference for meat pizza and preference for Little Caesars? So we're wondering if there's like any sort of connection between the way that people answered those 2 questions. So I told you that we're just going to keep our probabilities in terms of fractions today. Well, on this last problem, I'm actually going to turn these into a decimal. So let's take a look at the 9 out of 20. And if we were to divide that, that ends up being 0.45, or 45%. 3 divided by 3 is 1.0, or 100%. And so looking at our probabilities here in decimal form will make it very easy for us to compare them. And we can describe a statement about what may be going on between these two preferences. So notice how that if a person did not like Little Caesars, they were much more likely to prefer meat, because 100% of the people preferred meat, compared to the people over here that did like Little Caesars. Well, it was only 45% of those people that preferred meat, so it looks like those people were less likely to prefer meat. So let's see if we can put that here into a sentence. Something that we're noticing here is that if a person does not like Little Caesars, they are much more likely to prefer meat pizza. An alternate way that we could have said that is, well, if a person does like Little Caesars, they are less likely to prefer meat pizza. All right. So when you're ready, we're going to go ahead and turn over to the back. We're going to see if we can summarize some of our important ideas from today into that quick note box. And we're going to divide that box here into 3 sections. So we have 3 learning targets here for today. All right, so learning target number 1 here was to decide if 2 events are mutually exclusive. And what we saw in the activity is that if they are mutually exclusive, it means that we have 2 events that cannot occur together. In other words, there's no overlap. So in our activity, the mutually exclusive events would be like the probability of meat compared to the probability of cheese. So people had to decide one or the other. They could not say both. So there are 2 different groups of people when we have students standing up. All right, our second learning target here was to apply the general addition rule for any 2 events. So the general addition rule is used when we are finding the probability of A or B. And so we start by adding together the probability of A plus the probability of B. But then we saw in the activity that if there was any overlap, we would need to subtract that out. So we're going to subtract out the probability of A and B. Now, I'm just going to add a little note down here at the bottom that if events A and B, if they are mutually exclusive, so they cannot occur together at the same time, then the probability of A and B is just equal to 0. What which makes sense because if they cannot occur together, it would not be possible for event A and event B to happen together at the same time. So that's why when they are mutually exclusive, we didn't necessarily need this piece at the end. Well, really what was happening is that it was just a value of 0. So what's kind of nice about this version here of the formula is that it works 100% of the time. If they're not mutually exclusive, it allows us to subtract out the overlap. If they are, we know the overlap is just 0, so we don't have to subtract anything out. All right, and then we have one more learning target for today. So we're using two-way tables to find probabilities, including conditional probabilities. All right, so we're going to start here by putting in the notation that we used that included that vertical line. So that vertical line was the same thing as the word given. So this would be finding the probability of event A given that event B has occurred. So let's see if we can put this into just a short phrase off to the side here. This is the probability of A given B has occurred. And the strategy that we found helpful today with our two-way table when we're doing these conditional probabilities was just to simply cover up the parts of the table you don't need to answer the question. All right, so we're going to have a chance to get a little bit more practice with some of these big ideas from today. If you look at the Check for Understanding problem below, we have some data that was collected from a small high school. These students were asked, what subject area do you prefer, math or English? And for each student, their grade level was also recorded along with their response. So you'll notice that we end up with another two-way table. And the values inside the table are telling us how many students fell into that category. Notice how the table totals are already given to us here, the row totals and the column totals. There are some cases, kind of like with our class data that we calculated at the start, where the totals are not given to you at the beginning. If that's ever the case, I always recommend filling all of the totals in first, so that you have all of the numbers in front of you to work with in answering the questions. So we're going to take a little bit of time here to go ahead and work through each of these. There's like 7 pieces here for the Check for Understanding, and then we'll come back together and check in on these before we go today on your probabilities. So when we take a look here at part A, so first one, if a student was randomly selected, we wanted to find the probability that they're a senior who prefers math. Well, that's just going to be one little number on the inside part of our table. If we look at the seniors and we see how many of them preferred math, it was 40 of them. And that's just going to be out of the total number of students, because it just says if a student is randomly selected from the 250, we get 40 out of 250. All right, now the questions are slightly changing because now in part B, there is a condition that has to be met. So it says, if a student who prefers math is randomly chosen, what is the probability that they are a freshman? Well, what we can do here is go ahead and ignore this bottom part of the table because we're just looking at the students who preferred math, which was a total of 119, so that's our new denominator. And 20 of those students who preferred math were freshmen. Now, the question changes a little bit in Part C. It says, well, if a freshman is randomly chosen, what is the probability that they prefer math? Well, we're just focusing in on the freshmen now, so we get to ignore the whole right-hand side of our table. We can see that we have 64 freshmen, so that's now our new denominator. And out of those 64 students, 20 of them preferred math, so this probability is 20 out of 64. And you can see the notation there when I wrote it out like this with that little line. It's asking an opposite question. So the probability that they're a freshman, given that they prefer math, versus the probability that they prefer math, given that they are a freshman. So notice how that's changing what our denominator was. But in every single one of these situations, whatever's listed second here, whatever that given is, that always corresponds with the number that we're listing out for our denominator. All right, we'll take a look at the second part here. So the probability that someone prefers math and they are a freshman, so that's going to be that same value of 20, but this time it's back to our table total of 250 students altogether. In Part B, this one was interesting. It's another conditional probability. The condition is that they are a junior or a senior. So we can actually ignore these pieces, but we're going to look at both juniors and seniors for our grade level. So the total number of juniors and seniors altogether is how we got the 126. And then the total of those who preferred English would have been these two values here, that 31 plus 21 is how we got the answer of 52. All right, the probability that they were a sophomore or a senior, so those are mutually exclusive, which means they cannot overlap. Somebody cannot be a sophomore and a senior at the same time. So we're just simply adding the probability that they're a sophomore plus the probability that they are a senior. But notice how in the last one, there could be some overlap. The probability that they're a sophomore or they prefer math. Well, you could be a sophomore that prefers math. So what we have here is we've got the probability of the sophomores. Right here, this is the probability of preferring math. And we're subtracting out the people that were double counted. So the people that were double counted were the people who preferred math and they were also sophomores. And that's how we ended up getting that final answer there.